February 1942. Somewhere south of Gazala, Libya, the morning sun rose through the haze of dust and diesel fumes as a column of captured vehicles stood outside a makeshift repair depot. Among the burned-out trucks and shattered British carriers was a small, box-shaped machine the German mechanics had never seen before. It was painted olive drab, its lines awkward, its scale toy-like beside the Kubelwagens and Opel Blitz lorries that filled the yard. Yet something about its construction invited inspection. Welds were clean, bolts identical. Every panel fit with mathematical precision. On its grille, a single word stamped in raised steel letters, Willys. Unteroffizier Karl Heinrich noted in his maintenance journal. It appears to be an American light car built for rough terrain. 4-wheel drive, impossible for such a small vehicle. Transmission resembles nothing we have seen. The mechanics circled it like archaeologists around a fossil. They kicked its tires, checked the gear linkages, and argued whether it could possibly run without breaking its axles in sand. When they lifted the hood, they found a simple 4-cylinder engine marked Go Devil. 2.2 liters, 60 horsepower at 4,000 revolutions per minute. Numbers unimpressive on paper, but its layout was clean, logical, and modular. Spark plugs and filters were accessible without tools. The radiator could be removed in minutes. Everything was designed for speed of maintenance, not beauty. It violated every instinct of German engineering pride. There was no polish, no ornament, no precision machined allure, only utility. Oberfeldwebel Hans Kramer, a veteran mechanic from Munich, recorded his reaction in the company log. "We would never have built such a thing. It looks as if a blacksmith and an engineer argued and then compromised. Yet its simplicity is ingenious. Perhaps that is its secret." They started it using a hand-cranked battery, borrowed from a Panzer III. The engine caught instantly, idled smoothly, and responded with a steady note that sounded more industrial than military. When Kramer pressed the accelerator, the small machine lurched forward, climbed a pile of sandbags, and descended the other side without stalling. The observers laughed nervously. Then they grew silent. It was not a toy. It was a tool, one that ignored the rules of design they had been taught. Later that day, an engineer from the Africa Corps inspection team photographed the vehicle from every angle, sending the prints to Tunis with the note, "Recommend technical evaluation. May represent a new class of utility transport." The word Jeep appeared in their files for the first time, its origin unknown, its significance unrecognized. That evening, as the sun set over the Libyan desert, the small American machine sat between a captured Bren carrier and a damaged Panzer III. The Germans ate their ration bread and argued quietly about how a nation that built such a simple device could also produce aircraft and tanks in such numbers. For now, it was merely an oddity in their yard. But soon, this oddity would force them to rethink everything they knew about engineering and war. The Jeep's arrival in the Africa Corps inventory had been an accident of war. In January 1942, during the retreat of the British 8th Army from Benghazi, a supply convoy of the Royal Army Service Corps was caught between advancing Panzer III columns and Luftwaffe Stukas hunting along the coast road. When the smoke cleared, among the wrecked lorries and burning fuel drums stood 2 small 4-wheeled vehicles that had somehow survived the bombardment. They bore strange markings, U.S. ordnance stamps on the tools, a Ford script on the rear panel. No one in the German column knew what they were. The vehicles were hauled to a forward maintenance point near Derna for examination. Mechanics accustomed to repairing Maybach and Horsch engines gathered around the compact American machines and began disassembly. Within an hour, curiosity replaced skepticism, Every component could be removed with simple wrenches. The gearbox slid free after loosening just 4 bolts. The drive shafts used universal joints sealed against sand. Nothing was hand-fitted. Every part appeared standardized, interchangeable, as if mass production itself had dictated the design. Oberfeldwebel Kramer took one out onto the desert track. The 4-wheel drive engaged with a solid, metallic click. As the small vehicle rolled forward, he noted how its suspension flexed over rocks that would have jolted a Kubelwagen to a halt. At 40 km/h, it felt alive. At 60 km/h, it seemed to float. He pushed it harder, turning sharply onto a stretch of soft sand. Instead of bogging down, the Jeep clawed forward, its narrow tires slicing through where wider German tires would have buried themselves. Back at camp, the crowd around him cheered and laughed in disbelief. No one expected such a tiny machine to conquer North African terrain designed to swallow heavy trucks whole. The Kubelwagen, light, elegant, air-cooled, was considered the ideal desert car. But the Willys machine ignored elegance. Its engine was liquid-cooled, its chassis box-framed and reinforced. It shook, rattled, and roared, yet it refused to stop. The next morning, under orders from the local transport officer, a proper field test began. 2 Kubelwagens, 1 light Opel Blitz, and the captured Jeep would run a 50-kilometer circuit across mixed terrain, sand, gravel, and wadis. Each carried identical loads of spare parts and water. Temperature, 42 degrees in shade, wind from the south bringing fine dust that infiltrated every machine. Within the first 10 kilometers, the Kubelwagens began overheating. Their engines, designed for European climates, struggled with sand ingestion despite extended air filters. The Jeep, with its sealed carburetor and oil bath filter, maintained steady temperature. At 20 kilometers, the Opel bogged down in the loose sand. The Germans spent half an hour extracting it with ropes. The Jeep simply circled back, engaged low range, and climbed the dune in reverse to help pull. At the halfway point, the test officers switched drivers. Unteroffizier Heinrich, skeptical of the American design, took the wheel. He drove it recklessly to find its weakness, slamming gears, bouncing across stones. The steering remained tight. The transmission never protested. At one point, he deliberately stalled it in a depression, expecting it to sink. Instead, a quick clutch release and throttle sent it leaping free, showering sand behind like a fountain. The Kubelwagen crews watched in silence. Their own vehicles, though reliable on firm ground, lacked the torque to escape similar traps. A note entered into the technical evaluation log read, U.S. light car shows exceptional traction. 4-wheel drive with a low-range gear effective beyond expectation. Simplicity of control permits inexperienced driver operation. When they returned to camp, the Jeep's odometer showed 52 kilowatts. Oil temperature normal. Fuel consumption recorded at 11 liters per 100 kilometers, slightly higher than the Kubelwagen, but acceptable given terrain. The radiator held pressure, the brakes remained cool, and no bolts had loosened. Mechanics examined the undercarriage, expecting cracks or leaks. None were found. That evening, the field commander inspected the vehicle himself. A pragmatic man schooled in the doctrine of efficiency, he studied the American car in silence, then turned to his men. If they build these by the thousands, he said flatly, we are finished. The remark was entered in the company diary as a joke, but it carried a weight that none could dismiss. The next week saw the Jeep used daily for errands across the supply zone. It carried messages, spare parts, even wounded men lashed across its hood. Soldiers began calling it Der kleine Amerikaner, the little American. Its clutch never failed, its engine never overheated. In the fine powder dust that seized German carburetors, the Jeep's filters held firm. Where the Kubelwagen required careful throttle to avoid trenching itself, the Willys could idle through with brutal indifference. Captured reports from other sectors soon reached Africa Corps headquarters. Near El Agheila, Rommel's staff examined another Jeep recovered intact. In Tunisia, engineers of the 10th Panzer Division measured its clearances and photographed its undercarriage. Patterns emerged: identical welds, identical bolts, identical tolerances, each example built as if stamped from a single mold. For the first time, German mechanics confronted an industrial philosophy utterly unlike their own. The Jeep was not the product of artisanship, it was the embodiment of process. Every part existed to be reproduced quickly, replaced easily, and ignored until failure. It was not beautiful, but it was immortal in function. When the desert winds died and silence settled over the camp, the little vehicle sat outside the maintenance tent, its olive paint dulled by dust. A mechanic wiped the hood clean and traced the letters Willys MB with his finger. He could not have known that within a year, thousands of such machines would flood every battlefield from Sicily to Normandy, moving generals, medics, and infantry alike. What began as a captured curiosity would become a revelation, one that forced the Wehrmacht to confront the true scale of American industry. And that revelation began simply with a test drive in the North African desert. The disassembly of the captured Jeep began in earnest 3 days later under a canvas awning behind the 15th Panzer Division's maintenance area. German engineers laid its parts on a sheet of canvas, arranging each in meticulous rows: engine block, gearbox, transfer case, drive shafts, springs, differentials, steering knuckles, and axles. To them it looked crude. Castings showed rough surfaces, machining marks unpolished. Bolts were simple hex heads, washers standardized. Yet as they compared each piece, something extraordinary emerged. Not one required hand-fitting. Each component was built to an identical tolerance, interchangeable without filing or adjustment. The Jeep's powertrain fascinated the engineers most. Its 2.2-liter Go Devil L-head engine used only 4 cylinders but produced steady torque at low revolutions. At 2,000 RPM, it delivered 130 Nm, enough to climb grades that stalled larger 6-cylinder vehicles. The compression ratio was modest, 6.48 to 1, allowing it to run on poor quality fuel. A side valve layout simplified manufacturing and reduced moving parts, and the German mechanics noted that a single man could remove the entire engine in less than 30 minutes using only a block and tackle. Beside it sat the transmission: 3 forward gears, 1 reverse, connected to a transfer case that engaged the front axle with a short lever beside the driver's seat. When the lever was pulled back, the vehicle became a true 4-wheel drive machine. In low range, its effective gear reduction exceeded 6.1, doubling torque to the wheels. Nothing in the Wehrmacht inventory matched this combination. The Kubelwagen's rear-wheel drive depended on limited slip differentials and tire flotation. It lacked the brute mechanical grip the Jeep displayed. Suspension design drew even greater admiration. Each corner used semi-elliptical leaf springs arranged for articulation rather than comfort. In demonstration, the vehicle could climb a half-meter obstacle with one wheel while the others remained in contact with the ground. The frame, a welded ladder of box-section steel, twisted without cracking. The engineers realized this flexibility was deliberate, controlled deformation that preserved traction over rough ground. German designs pursued rigidity. The Americans had embraced elasticity. Tires were narrow, 6.0 x16, built of thick sidewalls and cross-ply construction. To German eyes, they seemed underinflated, yet their footprint spread wide across sand, providing the grip the light Kubelwagen could never achieve. Even more impressive was the simplicity of replacement. 4 bolts released each wheel, all identical, including the spare. The brake drums came off without special tools. Every assembly invited maintenance rather than defying it. They measured the dimensions carefully. Wheelbase 2.03 m, ground clearance 0.22 mm, curb weight 1,040 kg. Its power-to-weight ratio exceeded 15 HP per 100 kg, slightly higher than a Kubelwagen despite carrying heavier components. The ratio between simplicity and performance seemed almost impossible. One engineer recorded in his notes, "No wasted metal, no decorative lines. Every kilogram contributes to function." Comparisons with German field cars became inevitable. The Volkswagen Type 82 Kubelwagen weighed only 725 kilos and used the same 985cc engine as the civilian Beetle, producing 23.5 AP. On hard ground, it was efficient. On sand, it was helpless. Its air-cooled engine avoided radiator damage, but overheated under heavy load. Its suspension provided comfort on roads, but limited wheel travel. The Jeep's approach was the opposite: heavy, overbuilt, utterly indifferent to refinement. As testing continued, engineers noticed another subtle difference. German vehicles required careful operation, mechanical sympathy, and training. The Jeep demanded none of these. Any soldier could drive it within minutes. Controls were labeled in English words instead of symbols. Throttle, choke, lights. Pedals arranged in familiar order. Clutch on the left, brake center, accelerator right. Start procedure. Choke, ignition, press, nothing more. When reports reached Africa Corps headquarters, senior officers requested formal analysis. A team from the Waffenprüfungsamt in Berlin, Germany's weapons testing office, reviewed photographs and drawings. Their preliminary conclusion, later found in captured archives, stated, "The American light cross-country vehicle, Willys MB, exhibits design priorities inconsistent with German engineering tradition. Its conception favors quantity, interchangeability, and ease of maintenance over precision craftsmanship. However, the performance achieved through such methods is remarkable." In the following weeks, other captured Jeeps arrived from different fronts. Some bore Ford markings, GPW instead of Willys MB, yet their parts matched perfectly. Engines, gearboxes, even bolts were interchangeable across manufacturers. The concept of such standardization astonished German engineers accustomed to hand-fit assemblies. They realized that the Americans were producing machines as if they were ammunition, identical, disposable, and countless. A few officers proposed sending one of the captured vehicles to Stuttgart for reverse engineering, but logistics and pride delayed action. The desert continued swallowing equipment faster than Germany could replace it, while America built faster than anyone could count. As the engineers reassembled the Jeep, they found themselves infected by a strange admiration. The machine represented a philosophy alien to their culture. That perfection lay not in complexity, but in reduction. Every component existed for a reason. Every omission served a purpose. No prestige, no ideology, only results. By dusk, the Jeep stood whole again, coated in desert dust. A mechanic turned the ignition key, and the small engine answered with its steady industrial heartbeat. It was the sound of practicality, made audible. Around it, German officers debated horsepower, gear ratios, production estimates. None could yet express what they all sensed: that this little car, designed by anonymous engineers in faraway factories, embodied something larger than machinery. It was the distilled essence of American industry: standardization over sophistication, simplicity over show, speed over ceremony. And the men of the Africa Corps, trained to worship precision, were beginning to understand that a new kind of engineering war had begun, one they could not win by craftsmanship alone. By March 1942, the captured Jeep had become the most studied vehicle in the Africa Corps. Engineers kept it under a canvas tarp, treating it less as a trophy than as a riddle. They began a formal comparative trial against the Wehrmacht's trusted light vehicles: the Volkswagen Kubelwagen, the BMW R75 motorcycle with sidecar, and the Horch 901 field car. The tests were methodical, conducted on a stretch of gravel plain near Tobruk, where the desert offered every variety of surface: loose sand, baked clay, and uneven rock. In raw numbers, the differences appeared subtle. The Kubelwagen's 985cc engine produced 23.5 horsepower, the Jeep's 2.2-liter engine 60. Yet horsepower alone did not explain the gap in performance. The Jeep's torque curve was broad and flat. Its four-wheel drive transmitted power evenly to both axles through a 2.43.1 low-range gear. When one wheel lost traction, the others simply took over. The German vehicles, relying on limited slip differentials, stalled under similar conditions. The first comparative climb test required each vehicle to ascend a 35-degree slope of loose sand, 40-minute long. The Kubelwagen managed 18 meters before its rear wheels dug trenches. The Horch 901 reached 25 meters before overheating. The Jeep completed the hill, idled at the crest, then reversed down without strain. Observers timed it at 38 seconds uphill, 42 seconds descending in controlled low gear. A note entered into the report read, "Vehicle maintains directional stability under all throttle positions. Clutch heat negligible. Steering requires no correction." On turns, the contrast widened further. The Jeep's steering system, worm and sector design with 15.5.1 ratio, allowed a turning radius of 5.3 mm. The Kubelwagen required nearly 8. The difference meant that on narrow desert tracks, the German driver had to back and fill, while the Jeep pivoted effortlessly. In convoy operations, this agility promised time savings measured in minutes, but multiplied across thousands of vehicles. Hours of advantage. The suspension test surprised even the skeptics. Each vehicle crossed a row of wooden beams spaced at 1 millimeter intervals. The Jeep's leaf springs flexed violently, but returned to neutral immediately. At 40 km/h, the driver reported tolerable vibration. The Kubelwagen's independent torsion bars offered a smoother ride, but the vehicle scraped its undercarriage repeatedly. The Jeep's higher ground clearance, 220 mm against the Germans' 160, proved decisive. Rocks that tore the Kubelwagen's floor pan barely grazed the American chassis. Fuel consumption offered the only advantage to the German design. The Kubelwagen averaged 8 liters per 100 km. The Jeep required 11. Yet this difference diminished in real conditions. The Kubelwagen's lighter engine demanded high revolutions to maintain speed, straining components and raising temperatures. The Jeep ran cooler and accepted lower-grade fuel without complaint. Mechanics observed that its oil bath filter captured desert dust more efficiently than the paper elements in German engines. After 200 kilometers, the American engine's internals were spotless. The Kubelwagen's carburetor already showed grit. Maintenance became the most revealing category. Replacing a clutch on the Jeep took 2 men 45 minutes. On the Horch 901, the same task consumed 3 men and 4 hours. The reason lay in the Jeep's modular layout. Every assembly, engine, transmission, drive shaft, differential, was mounted with uniform bolts accessible from above or below. German vehicles, designed by separate firms to distinct standards, shared few common tools. The Jeep's entire mechanical system could be serviced with a single wrench set and screwdriver. The psychological impact was severe. German mechanics prided themselves on craftsmanship, on precision measured in microns. The Jeep functioned on the opposite principle: tolerances deliberately wide enough to allow mass production and easy repair in field conditions. It forgave rough assembly, accepted imperfect parts, and continued running where German machines demanded laboratory precision. One inspector wrote, reluctantly, "The American vehicle's rough manufacturing does not hinder its performance. On the contrary, the lack of precision contributes to its endurance." Another noted, "Our vehicles are designed to be admired. Theirs are designed to be used." When officers examined cost calculations, admiration turned to unease. A Kubelwagen required roughly 900 man-hours to produce. The Jeep, 150. The American factories achieved this by stamping components from dies and welding instead of riveting. German production, still rooted in small-batch craftsmanship, could not compete. For every light car Germany produced, the United States could build 6 Jeeps. In one experiment, the mechanics deliberately removed random bolts and loosened fittings to simulate battle damage. The Jeep continued operating until more than half its fasteners were gone. The frame creaked, the steering wandered, but it did not fail. By contrast, a Kubelwagen with a cracked torsion bar or jammed cooling fan became useless. The final entry in the comparative report summed up the verdict with clinical precision. The Willys light vehicle demonstrates superior cross-country mobility, greater structural resilience, and easier maintenance than current German models. Its performance under poor lubrication and high dust load exceeds expectations. It lacks refinement, but exceeds requirement. That single sentence, typed on onion skin paper and sent to Berlin, quietly marked a turning point. For the first time, German officers admitted that technical elegance had lost its supremacy. They had witnessed a new principle: function without ornament, power without pride, and though they did not yet name it, they had just defined the future of mechanized warfare. The more they studied the Jeep, the clearer it became that its power did not lie merely in its design, but in the system that produced it. Every piece of metal, every bolt, every stamped panel told the same story: precision born not of craftsmanship, but of repetition. When the Africa Corps' engineers examined the markings on the differential casing, they found factory codes from Willys Overland in Toledo, Ohio. On another Jeep captured weeks later, the same part bore an identical code, except the casting had come from the Ford plant in Dearborn, Michigan. 2 companies, 1/600 kilometers apart, producing parts that fit together perfectly without adjustment. To German industry, trained in bespoke tolerances and secret patterns, this was unthinkable. By early 1943, German intelligence in Tunis compiled a technical dossier titled American Light Vehicle, Model Willys MB, Ford GPW. Its conclusion was terse. Identical construction across manufacturers suggests complete standardization of dies, tooling, and assembly. Such coordination is possible only through centralized production planning and mass stamping. The report reached the Reich Ministry of Armaments, where it disturbed more than impressed. Albert Speer, recently appointed armaments minister, read the file and remarked to an aide, "They are building machines as if they were munitions." He was not wrong. The American production model defied every convention of European industry. Where German factories produced vehicles in batches of hundreds, Willys and Ford were building them in tens of thousands. By the end of 1942, assembly lines in Toledo, Dearborn, and Louisville turned out nearly 700 Jeeps per day. By 1945, total production would exceed 640,000 units. The process was relentless, continuous, components arriving hourly by rail, stamped, welded, painted, and shipped with no idle time. Photographs later recovered from U.S. Signal Corps archives showed the choreography of this mechanical ballet. Body shells suspended from overhead conveyors, engines lowered by hydraulic arms, torque wrenches clicking in unison. Women in factory overalls tightened bolts, inspected welds, and rolled completed vehicles to test bays. A Jeep came off the line every 90 seconds, each identical to the last, each ready for shipment by rail or cargo ship to distant continents. The technical genius lay not in any one engineer, but in the system itself. The Willys MB had been designed around manufacturing efficiency. Flat panels that required minimal forming, symmetrical parts that could be installed on either side, standardized bolts across the entire chassis. The rear fenders matched the front. The headlamps flipped inward to illuminate the engine bay during night repairs. Nothing required a craftsman's touch. Everything obeyed the logic of the assembly line. German observers who saw these photographs in 1943 realized the strategic meaning instantly. For every damaged Jeep destroyed in the desert, another would leave the factory before the wreck cooled. No shortage of parts could halt its advance. Replacement components, gearboxes, axles, brake drums, were shipped worldwide in wooden crates marked Jeep units. Field mechanics could rebuild one from the frame up in a single day. A captured U.S. quartermaster manual found at Kasserine spelled out the philosophy in unemotional English. Replace, do not repair. That sentence explained more about American power than any weapon. Germany prized restoration, precision, reuse. America treated machinery like ammunition, expendable, replaceable, infinite. Within the Africa Corps, mechanics began to use the Jeep as a workshop mule. It hauled generators, water trailers, and wounded men from the front. The machine demanded nothing except fuel, which it consumed modestly. When a tire shredded, a captured American spare fit perfectly. Even bolts from different batches threaded without resistance. Every discovery confirmed the same principle. The Americans had industrialized reliability itself. In Berlin, the intelligence summaries turned from curiosity to alarm. If the United States could mass-produce such vehicles faster than Germany could destroy them, numerical advantage would soon become absolute. One engineer at Daimler-Benz, reading the translated report, scribbled a bitter note in the margin. We engineer art. They engineer multiplication. The Jeep was not simply a transport. It was proof that American industry had mastered what Germany had only theorized: total standardization. A factory in Detroit could be bombed, and production would continue in Toledo without a single blueprint change. Every part, every process, every worker fit the same industrial rhythm. The desert mechanics of the Africa Corps could not see the vast foundries that fed this rhythm, but they felt its consequence. Each time another convoy brought more captured Jeeps, they realized they were looking at the physical manifestation of a nation's industrial will. The small car, built from stamped steel and common bolts, was more than a vehicle. It was the most portable expression of American mass production, the machine that turned logistics into victory. By the time the Allies landed in Sicily in July 1943, the Jeep had already transformed from a curiosity into a constant presence. Its boxy silhouette appeared on every road, every beach, every forward strip of dust that could hold 4 tires. What had begun as a lightweight reconnaissance car became the nervous system of Allied mobility, a single platform performing 100 duties without complaint. In the 1st Infantry Division, Jeep convoys replaced motorcycles for message runs. The small 4-wheeler could cross rubble, ford shallow rivers, and climb slopes too steep for 2 wheels. Artillery units used it to tow the 37mm anti-tank gun. Later, even the 57mm when roads permitted. A medical team discovered it could carry a stretcher on brackets welded to its sides. Within weeks, Willys issued official ambulance kits. Communication sections mounted radios on its rear deck, converting it into a mobile command post. Engineers bolted racks for bridging equipment, mines, and wire reels. It was not one vehicle. It was every vehicle that the front required. Photographs from Operation Husky show Jeep columns rolling through the Sicilian dust, windshields folded flat, flags snapping in the prop blast of C-47s above. Their engines droned in perfect synchronization, a symphony of identical notes built in Toledo and Dearborn. When the landings expanded into Italy, Jeeps were among the first machines to reach Naples, their tires squealing on cobblestones laid by the Romans. British Eighth Army officers, initially skeptical of the American design, requisitioned hundreds. Field Marshal Montgomery's personal Jeep, marked Monty on the bumper, became a familiar sight. Everywhere it went, the vehicle proved immune to environment. In the deserts of Libya, it endured 50-degree heat without boiling. In the snow of the Apennines, it started after nights below freezing. Soldiers learned to trust its simplicity. A broken fan belt could be replaced with parachute cord. A punctured radiator sealed with pepper or soap. The manuals encouraged improvisation, and the machine forgave it. In North Africa, German observers had first called it a toy. In Italy, they learned otherwise. Reports intercepted by the Abwehr described small American cars able to move over ground, where even tracked vehicles struggle. At Salerno, German troops found Jeeps bringing ammunition directly to forward lines, their silhouettes darting through shell fire, engines echoing like insects. One Wehrmacht officer wrote in his diary, "We shoot at them constantly, yet they never stop. When one burns, another appears." The Allied advance through France in 1944 turned the Jeep into a global symbol. Patton's Third Army moved with them in endless convoys, headlights covered by blackout slits, exhausts popping in unison. Each Jeep carried extra fuel cans, ration boxes, and rifles clamped to the windshield frame. The Red Ball Express, the lifeline from Normandy to the front, depended on them to scout routes, escort convoys, and ferry wounded back down the line. American correspondents described them as the steel horses of a mechanized army. In the Pacific, they adapted again. Jeeps splashed from landing craft onto coral beaches, fording surf that would have drowned heavier trucks. Marines used them to drag supply sleds, tow 75mm pack howitzers, and carry stretchers from jungle clearings to field hospitals. Engineers added snorkel kits for river crossings and mounted machine gun pedestals for perimeter defense. When roads ended, Jeeps kept moving, their narrow track carving new ones. Pilots who landed on rough airstrips often found Jeeps waiting beside their aircraft. They became mobile control towers, their radios linking air and ground in real time. At Guadalcanal, one was converted into a generator platform to power the searchlights that guarded Henderson Field. Another, fitted with wooden planks, served as the island's first fire engine. What most astonished Allied officers was not the Jeep's performance, but its endurance. It required little care and even less respect. Soldiers overloaded it, misshifted gears, left it idling for hours, yet it continued to run. In Italy, a unit of the 34th Division drove one 11,000 kilometers without replacing a single major component. When parts finally wore out, replacements came in canvas sacks labeled Jeep Field Set A. In the files of the U.S. Army Quartermaster Corps, a memorandum from December 1943 summarized its impact in one clinical line. The 1 4-ton truck has become indispensable to all arms of service. That bureaucratic understatement hit a revolution. The Jeep was not merely transport. It was the bloodstream of Allied warfare, pumping men and orders through every artery of the global front. And as German soldiers watched them multiply across the Mediterranean, a deeper realization began to form. This was not just a machine. It was the visible proof of a system capable of sustaining war anywhere, on any terrain, without pause. The Wehrmacht still fought by craftsmanship. The Allies now fought by circulation. By late 1943, the Jeep had become more than a battlefield machine. It was a mirror reflecting everything the Germans had refused to believe about America. For the officers of the Africa Corps, now serving in Italy, the sight of convoys filled with hundreds of identical jeeps stirred something close to disbelief. They had watched these vehicles climb slopes that defeated tanks, start in freezing rain without preheating, and roll through mud that swallowed half-tracks. It was not the performance itself that unsettled them. It was what that performance implied. Captured documents soon confirmed what their eyes already knew. The Technical Intelligence Bulletin number 312, recovered from an abandoned U.S. command post near Anzio, contained precise statistics. Monthly production of 35,000 units, interchangeable parts across every plant, repair time under combat conditions measured in minutes. A single line underlined in red pencil read, Willys MB assembly time, 2 hours, 24 minutes. To German officers accustomed to the slow ritual of hand-fitted construction, that number was incomprehensible. At a depot outside Naples, a group of captured German engineers was ordered to evaluate several wrecked Allied vehicles. Among them was Oberingenieur Franz Rausch, formerly of Daimler-Benz. His later interrogation report recorded his astonishment. The American Jeep is not refined. It is brutal in design, but it is perfection of purpose. Every hole is punched where it must be, no more, no less. The entire philosophy is foreign to us. They disassembled one burned-out Willys chassis and found that even the parts distorted by heat could still be fitted to another frame. Bolts turned freely, threads matched. Rausch wrote, "They build with excess, material, tolerance, manpower, yet nothing is wasted because the system consumes it all." Other prisoners, trained mechanics from the Africa Corps, were assigned to repair captured jeeps for Allied service. One diary recovered years later by American historians contains a terse admission. "We fixed the enemy's machines and learned humility. They ran better after months in the desert than ours did after a week in depot." Back in Berlin, the Armaments Ministry tried to interpret the reports. Analysts in Speer's office compared the Jeep's production data to the Reich's entire automotive output. The results were alarming. America had built more Jeeps in 1943 alone than Germany had produced military vehicles since 1939. Their conclusion, written in cautious, bureaucratic language, stated, "The enemy's success rests on mechanical democracy, the same machine for every man, the same standard for every task." For German officers steeped in hierarchy and tradition, that phrase carried a sting. The Jeep seemed to embody the very social order they had dismissed as decadent, open, improvisational, indifferent to rank. Generals rode in the same vehicle as privates. Field marshals drove with grease on their uniforms. It violated every code of military distinction, and yet it worked. A captured German war correspondent near Cassino described the shock in his notes. "Their generals drive these little machines themselves, without chauffeur, without ceremony. It is as if their democracy has wheels." Another officer, interrogated at Trent, summarized it more bitterly. "We built cars to show superiority. They built one to serve everyone. Perhaps that is why they will win." Psychologically, the effect was corrosive. German mechanics began to speak of the Willys with a strange respect, almost affection. They borrowed American phrases, calling it the Jeep instead of translating the name. Prisoners tasked with repairing them often requested to keep working on the same models, claiming they wanted to understand the simplicity. The shift ran deeper than admiration. The Jeep revealed to them that the enemy's strength came not from individual genius, but from organized abundance, a unity of factory, worker, and soldier that no dictatorship could replicate. America's democracy had produced not chaos, but coordination on a scale the Reich could never achieve. When one officer asked Rausch what he thought of the American car after months of study, he answered with quiet resignation, "It is not the machine that defeats us. It is the idea behind it." That realization spread through reports, diaries, and interrogations. The little four-wheeled vehicle, once dismissed as a curiosity, had become the symbol of a deeper truth, that the war of machines was also a war of systems, and Germany's system, elegant but brittle, was beginning to fracture under the weight of its own pride. By 1944, Allied commanders no longer saw the Jeep as merely a transport vehicle. It had become the purest symbol of a new kind of warfare, one built not on brilliance or prestige, but on standardization. The machine's very ordinariness was its strength. It could be shipped in crates, dropped by parachute, reassembled by two men with a wrench, and run immediately. There were no secrets inside it, only a philosophy: mobility over glamour, practicality over pride. Across every front, the Jeep served as a moving demonstration of America's industrial doctrine. Where Germany's war economy pursued perfection, America pursued momentum. The Jeep was designed to be built fast, repaired faster, and replaced fastest of all. Its success lay in how it embodied the nation that made it, a democracy of machines where every part, like every citizen, had its place and function. When General Dwight D. Eisenhower wrote years later that four machines had won the war, the C-47 transport, the landing craft, the bazooka, and the Jeep, he was not indulging sentiment. Each represented a system of thinking, and the Jeep system was simplicity. It could be driven by a mechanic, a medic, or a general with equal ease. It did not need loyalty. It needed fuel. Captured German intelligence summaries began describing the Jeep in abstract terms. One report from February 1944, found later in a Berlin archive, noted, "The enemy's light transport demonstrates how industrial democracy applies to the battlefield. Production is decentralized, yet unified by identical patterns. The result is quantity without loss of quality." That observation cut to the heart of what Germany could not duplicate. The Reich's industrial empire was centralized, rigid, and obsessed with hierarchy. Factories competing for prestige rather than cooperating for output. America's network functioned like the Jeep's drivetrain. Multiple power sources feeding one motion. Each factory, each worker, each design team meshed into a single forward gear. The Jeep's very appearance on battlefields from Burma to Brittany showed what that meant in practice. It linked the world's largest coalition of armies into one moving organism. British, Polish, Canadian, Free French, Australian, and Soviet forces all used it interchangeably. Spare parts shipped from Kansas fit vehicles assembled in Ontario and repaired in Alexandria. Even paint colors matched. No empire in history had ever achieved such mechanical unity. In strategic terms, this standardization multiplied time itself. Every hour saved in repair was an hour gained in advance. Every part that fit another vehicle erased the logistical paralysis that had crippled armies since antiquity. American officers called it the mathematics of movement. German planners studying Allied supply efficiency after Normandy called it something colder, the tyranny of interchangeability. To the Allies, it was liberation. To the Axis, it was exhaustion. Wherever the Jeep appeared, it brought with it the infrastructure of abundance: gasoline, spare tires, food, and communication. The vehicle that could carry an officer one day might haul ammunition the next. It was utilitarian democracy in motion, blurring the boundaries between classes, ranks, and roles. Even Soviet officers who distrusted Western technology came to admire it. In the winter of 1944, near Kursk, Red Army reports described American Lend-Lease Jeeps as machines that will run until nothing is left but the steering wheel. The phrase became legend among Soviet drivers and entered folklore as proof that endurance, not elegance, wins wars. In Berlin, strategists watched the reports accumulate and drew the inevitable conclusion. The war had become industrial arithmetic, and America had solved the equation. Its weapons were not masterpieces, but instruments of rhythm, repetition, and repair. The Jeep, small and unremarkable, was the clearest expression of that rhythm. It represented the death of the artisan soldier and the birth of the production soldier, men and machines synchronized into one continuous motion. As one German analyst wrote in a final report before the war's end, "The Americans have built a weapon that is not destroyed when it is lost. It reappears endlessly, identical to itself. It is the embodiment of mass." And that realization, more than any defeat on the battlefield, marked the moment Germany understood the future had already arrived, stamped, crated, and driven on 4 wheels. When the guns finally fell silent in 1945, the Jeep remained everywhere, scattered across Europe, Asia, and Africa like mechanical fossils of an empire of supply. Some were abandoned in fields, others kept running by civilians who had never seen such reliability before. In ruined German towns, engineers from Volkswagen, Opel, and Daimler studied the captured vehicles with a new kind of humility. The lessons were unmistakable. The age of the handcrafted automobile was over. The age of the standardized machine had begun. In Wolfsburg, as Volkswagen engineers restarted production under British supervision, the Kübelwagen's legacy quietly merged with the Jeep's philosophy. The Type 82's lightweight frame became the basis for post-war civilian designs, simplified, modular, reproducible. Across Germany, surviving engineers who had examined the Jeep during the war introduced its principles into the new automotive order: interchangeability, accessibility, functional minimalism. What had once been dismissed as crude became the new definition of precision. By the 1950s, factories in Stuttgart and Munich were retooled for mass production on American lines, conveyor belts, stamping presses, standardized components. The miracle of West German recovery, the Wirtschaftswunder, rested partly on those lessons. Engineers who had studied captured Jeeps now designed civilian cars with the same philosophy. Vehicles ordinary people could own, maintain, and afford. The elitist engineering that had once glorified craftsmanship gave way to the democratic engineering of function. Globally, the Jeep's influence spread even further. In Japan, Toyota engineers rebuilt their destroyed plants by copying its simplicity of frame and layout. In France, the Citroën 2CV echoed its minimalism. In Britain, the Land Rover borrowed its stance and dimensions almost bolt for bolt. Even the Soviet Union's Gaz factory produced near replicas under the name Gaz 67. Each variant carried a trace of the same industrial DNA, the belief that strength lay in standardization, that reliability was a kind of freedom. Among soldiers who had driven them, the Jeep remained a symbol of endurance. It had carried generals through bombardments, delivered medics to the wounded, and survived every climate on Earth. In post-war parades, it appeared beside tanks and aircraft, unglamorous yet indispensable. Eisenhower later wrote, "Without the Jeep, we could not have won." For once, no one argued. In Germany, a few veterans of the Africa Corps still remembered the first one they had seen under the desert sun in 1942, the odd little American car they had tested and mocked before understanding what it truly meant. In interviews decades later, one of them, A former mechanic named Heinrich Müller summarized the revelation that had haunted him ever since. We built machines to serve our pride. They built one to serve everyone. And in that difference, they defeated us. The Jeep outlasted the war it was built for. It became the pattern for peace, an object born from necessity that taught nations how to think in systems, not symbols. Its boxy frame carried no ideology, only utility, and through that utility, a quiet form of equality. On every continent, from muddy farm tracks to city streets, descendants of that first Willys still move with the same rhythm, steady, unpretentious, unstoppable. A machine that asked for nothing but fuel and faith and gave in return a glimpse of what industry could achieve when it served humanity instead of ambition. And so, what began as a captured curiosity in the North African desert ended as the blueprint for the modern world. 4 wheels, a flat hood, and the enduring proof that simplicity, multiplied 1,000,000 times, can reshape history.